Grace and peace to you all, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Reviewed. Okay, so today's question, we are looking at differentiation from first principle. Okay, so we have differentiate the function f of x is equal to cos x, and 2 f of x is equal to sin x using the first principle. Okay, so the first principle states that if you have f of x and want to differentiate, so it will be f of prime x is equal to, you have limit of f of x plus h minus f of x over h as h approaches 0. So this is the formula for first principle. Now we have f of x is equal to cos x. So where there is f of x, you will just put cos x. Okay, so this is a derivative. So we'll say d dx of cos x is equal to limit as h approaches 0 of, so f of x plus h, where there is x we put x plus h. So we are going to have cos of x plus h minus, then f of x is cos x. So we have cos x over h. Okay, so we have d dx of cos x is equal to limit as h approaches 0. Then we need to expand cos x. So how do you expand cos x? You have cos x multiplied by x, so that is cos x. Again, cos multiplied by h, we get cos h, then minus, this is how you do it, sin x and sin h. Okay, then there we have minus cos x over h. Okay, so we have dx of cos x is equal to limit as h approaches 0. We can rearrange the terms here. Cos x, cos h will go with minus cos x. So we have cos x and cos h minus cos x. Then we have minus sin x sin h over h. Okay, then we have dx of cos x is equal to, so limit as h approaches 0 of, here we can divide out the cos x. So we are going to have cos x, then in brackets we are going to have cos h minus 1, then minus sin x sin h over h. Okay, then from here we can separate these two. We know that since we are dividing this by h, we can have this by h and this sin x sin h over h. Okay, you separate the two. So we are going to have d dx of cos x is equal to limit as h approaches infinity. You can put this in brackets. We have cos x cos h minus 1 over h minus sin x sin h over h. Okay, then here we are going to distribute the limit. So we are going to have it will be limit of cos x cos h minus 1 over h. Now, since this cos x doesn't have h. It is more of a constant. So you can write it outside the limit. So it will be cos x, then limit as h approaches 0 of cos h minus 1 over h. Even here, the sine x doesn't have an h, so it will be outside the limit. So minus sine x, then you have limit as h approaches 0 of sine h over h. Okay, then we have d dx of cos x is equal to what we should remember from limits is that a limit of cos h minus 1 over h as h approaches 0, this one is a 0. Okay, so the limit of cos h minus 1 over h as h approaches 0, this is a 0. So we are going to have cos x multiplied by, this is a 0, so minus sine x, then again limit of sine h over h as h approaches 0, this one is a 1, so multiplied by 1. So you get d dx of cos x is equal to cos x multiplied by 0 is 0. That is, n number multiplied by 0 is 0. So there we have 0 minus sine x multiplied by 1, you get sine x. Okay, so we have d dx of cos x is equal to 0 minus sine x, you get minus sine x. So you can see that the derivative for cos x is equal to minus sine x. So we have differentiated cos x with respect to x using first principle. So this is how you do it. Thank you for your time.